Do we not have image? What's happened? What the? What's the story here? Where's my picture? Oh, good. We're in action now. Just took a minute. Okay, so this one on the bottom of 144, I asked you to differentiate. And for this particular question, because it was the last question on the page, I do ask you to simplify this. So, let's write this down. We have to differentiate x sine x plus 9 over log 8x plus 4. It's okay? You can see okay? Yeah. So what rule do I need first?
Quotient rule.
Quotient rule first.
Into a product.
And the chain.
Yeah, and a chain.
Yeah. So first the quotient rule. The bottom squared.
Bottom squared.
Okay, so far. The bottom derivative of the top. So that's 1 sine x plus 9 plus x times the derivative of sine. Derivative of sine x plus 9 is cos x plus 9, and the derivative of x plus 9? 1. So that was the chain rule at the end of the product rule. Now back to the quotient rule. Minus the top times the derivative of the bottom.
1 over 8x.
Yeah, so we need a chain rule for log. Log is 1 over x, which in this case is 1 over 8x plus 4. Then we multiply by the derivative of 8x plus 4, which is 8. There's only really two things I can do to simplify this. There's not much that groups together or simplifies. What could I do? No, because I actually asked you to simplify here. If you can read 3 words, yeah?
You can remove log 8x plus 4 and 8x plus 4.
1 sec. Yeah, well, the first thing, let's get the easy thing first. Let's get rid of this 4 in these 3. Yeah? So that's 2, 2, and 1. Okay. Now, what's next? Yeah?
The 2x plus 1, multiply both the top and the bottom by 2.
Yeah, multiply the top and the bottom by 2x plus 1. So when you multiply the top by 2x plus 1, you get 2x plus 1 log 8x plus 4 bracket sine x plus 9 plus x cos x plus 9, close the bracket, minus 2x sine x plus 9. The fraction is gone because I multiplied by x plus 1. And we multiply the bottom by x plus 1 as well. Log 8x plus 4, close bracket, bracket squared. Okay. There's not anything else I can do to simplify. For example, if I open this bracket, I will produce a log sine and a log x cos. And I could combine the log sine with the other sine here. But I'd be in exactly the same situation as before, except rather than having a log out here, I'd have a sine. In other words, I can't do any better than having one thing grouped out, factored out, and one piece with nothing to factor out. There's nothing I can divide, and there's no point in expanding.
The bottom.
What?
The square.
What about it?
Can't you expand it?
No, I can't.
Or multiply it.
But that's making it more complicated, because now instead of writing one thing, I write 2. I write log log.
Yeah.
Which power? Oh, that's what Andrea was asking me. You can't. There's nothing to cancel with it on the top.
But if you multiply by 1 over 2.
Multiplied by
1 over 2.
where?
The top.
The top.
Can you cancel?
Cancel which?
Like if you bring the bottom to the other side, and then like...
Hang on, you're confusing me. Bring what to where? Are you sure?
Yes.
Trust me, you can't simplify it.
Sorry, if you multiply x plus 1 to the upper fraction, you won't get the 2x. You can simplify it.
You can't.
Where do you get the?
If you multiply the 2x in, we'll get 2x, you'll get a 2x, if you were to swap these guys, right?
I mean the second part, the fraction
On the top or on the bottom?
on top.
Which part?
I mean 8 over 8x plus 4, and you simplify it.
Oh yeah.
And if you multiply by x plus 1, you can just eliminate the fraction.
Yeah, I did that. That's the way the x plus 1 is gone here.
No, you can't.
What do you mean I can't? I can do anything I want. I'm Stephen.
It's 2x plus 2.
Oh, sorry. Yeah, sorry. You're right. You're right,
Two
Peng.
X plus one.
I forgot to write a 2
Yeah.
here. Thank you.
This one.
Thank you. I missed my 2 there. Yeah. I multiply the top and bottom by 2x plus 1, not x plus 1. Yeah. Yeah.
Why don't you expand? I understand that you said that you can't go any further, but wouldn't putting it in simplest form mean that you expand as well?
Not necessarily. Like, I'll give you an example here, okay?
Even in your answer you provided it was expanded.
Was it?
Yep. 3 terms.
Oh yeah, okay, expanded, yeah.
That's the exact same answer I found.
Yeah. It really, really depends on what you consider simpler.
But it won't come in the exam, right?
No, if it came up in the exam, the simplification would be obvious, like two things will cancel. You know?
Okay, can I get one question?
Yes? Go on.
Remember, I had a
Yeah.
144. J.
Yeah. 144, which one?
J.
But which question?
2J.
2J. Okay.
H.
144. 2J. What is it? 1,
Oh,
3 e 3x root 1 over root x. Now look, I can think of at least 3 different things I could do to start this, and as a result your answers will look slightly different. But it doesn't mean that your answers are different, just that you took a different way to get to the answer. And since they don't care about simplifying in the exam usually, it doesn't really matter. So you have a couple of choices here. You can think of this as a double chain rule. You could think of this as a quotient rule. Or you could think of it as neither chain or quotient and simplify this to a power.
Yeah.
that was the
If that's what most people did, that's good, because I think that would be the easiest part. So to get this as a power, it would be first, the whole thing is power a half, and then inside is x power minus a half, because that's what 1 over root x is. So this is 3e 3x, x minus a quarter. And now we just need only the product rule. So that's 9e 3x plus 3e 3x times minus a quarter x minus 3/4.
Chain rule?
Product rule.
Plus.
Oh, okay.
There isn't a need to simplify, but I really, it's so obvious that you can take out this. I might as well. So I'll have e 3x bracket 9 minus 3/4.
sorry, you missed
You missed the 3.
Which 3 did I miss?
Not,
The
you,
9
took,
and 3.
you can take 3 as a common factor. It's so obvious.
Is it so obvious? You're right, it's pretty obvious. Okay, 3e 3x, thank you. I had a pretty big lunch in the mosque, so I'm a bit sluggish.
Why don't you include the x to the power of minus a quarter in the after 9e3x?
Oh, for goodness sake, I really can't have those vegetarian curries. X to minus a quarter, thank you. Thank you. Thank you. This is what happens when you have rice and naan bread. Okay, so let's see. I can... Huh?
Both. One time.
Both, yeah.
What are you having it with?
Yeah, the veg curry that he has was good. 3e 3x bracket 3x power minus a quarter x power minus 3/4. Yeah, thank you.
Plus,
I don't see how you could do it as a quotient rule.
Are you asking me a question because you have one question left?
Huh? I have 2 questions.
No, you don't. I've been keeping
I've
track.
asked 1.
No, don't contradict me because you can watch the video. In fact, we can play a game. Everybody can watch the video and post how many questions he's asked.
I am done. I'm actually done.
You have one question left.
Okay. If
You're using it now.
Yes, I will be using it now.
Oh, that's 15
Oh,
minutes.
okay, go ahead.
Okay.
Make it good.
But there is a bet with it. If this is my last question and
Yeah.
I go to the video and I prove that I've asked only 2,
I don't
my
know.
questions are upgraded to 5 on every single period. It's only fair enough, you know. It's so obvious that
Let's
I've asked big
see.
questions.
I'll choose no. All right, I'll tell you what. I'll give you the 2 more questions because I'm such a stupidly nice guy. Okay, so go ahead. Use one of your 2.
I don't see how we could have solved it as a quotient rule. So how do we solve it as a quotient
Fair enough. So, how would you approach this as a quotient rule then?
rule?
Okay. Well, does anyone need to? Can I scroll down and look at it as a quotient rule? No, I'll just go back up here so I don't have to rewrite it. So I'll just copy it over here. So this is 3e 3x root 1 over root x. So you could just go straight into quotient rule, but maybe before you do that, just put in halves instead of roots, okay?
Isn't that what we do?
No, but now, I won't count that as a question, because I know you didn't mean to ask me that. So what I'll do now is I'll use the product rule. So that's 9e3x, okay? That's okay so far. And then you keep this the same, so there's nothing crazy happening yet. Then you keep the 3e the same, like that. Now you need the chain rule here. So you bring down the power and reduce the power by 1 and keep the inside the same. Then you multiply by the derivative of the inside, which you can think of as a quotient, which is the bottom squared. So x power half squared is x. Then it's the bottom times the derivative of the top minus the top times the derivative of the bottom, which is a half x to the minus a half. You see? Now believe it or not, that actually is the same as the other answer. You can show that.
Yeah, because you get a quarter.
Any other ways we can think about it? If you didn't down here, you see the way I multiplied the powers? If you didn't multiply the powers here, you could view this as a chain rule. Bring down the power, reduce the power by 1, multiply by the inside derivative.
what about keep it as 1 over x in half, putting the 3e or 3x over.
You can't.
Oh, yeah, no, I like this too. I see what you're saying. So you could write it as 3e 3x over x power a quarter.
Yes.
Oh, that's a quotient rule and a product rule. No chain rule. You see? So the way it's set up is, it seems like you have to use 2 rules. So here it's a product and a quotient and a product. And the way we did it was a product and a chain. And then the way over here was a product
Quotient
and a quotient
and a chain.
and a chain.
It's just
So this is the most inefficient way to do it. Yeah. Yeah. So I mean, in the exam, it doesn't usually happen like this. You know, they keep it a bit more to the point, like x sine x over, I don't know, ex or whatever. Just a bit more straight to the point. Okay. Right. Who are we back to with questions? Yeah. Go ahead.
Page 146.
Which one?
Yeah.
12D. You gave it a go?
Yeah. Need help.
Yeah. How close do you think you got to the answer?
I just got it.
Which
Trying
page?
to write the example.
146D.
Okay.
Yeah,
12D on 146.
Oh,
If we could do E and F as well, like, just get it over with.
But maybe when I do D, you'll find E and F easy.
Sure.
That's very convincing. Right. Y equals sine inverse x. And we're trying to find dy dx. Okay? So, we don't know the derivative of sine inverse. What we'll do is we'll apply sine to both sides. Sine y equals sine inverse. So it's just x then, like that. Now, we have our implicit derivative here. Come on, get off the phone. Are you on the phone too?
Yeah.
Okay. What are you looking up?
Something that I'm probably wrong at and I don't want to ask a question. So,
Okay, fine. If you're only looking up maths, that's okay. Right, so we need implicit derivative here. So sine y becomes cos y, dy dx, and x becomes 1. So is this what you said, Arya, that you got? Dy dx equals 1 over cos y, which of course isn't the answer at the back. But the reason for that is we have a y and we want an x. How do we change that? Right, let me draw a triangle here. Let me call this side x and this side 1. And this side y. What's sine y equal to? On this triangle, what's sine y equal to? X over 1. So what would y equal? Sine inverse x. Yeah? This triangle is representing exactly this equation. Therefore, from this triangle I can get what the cos y must have been. We need to get this base. We can get that using Pythagoras, which would be square root 1 minus x squared over 1. What's 1 over cos y equal to? If we reciprocal both sides, what do we get on the right? 1 over root 1 minus x squared. So that's 1 over cos y, but 1 over cos y is dy dx. So the answer is this, 1 over root 1 minus x squared, which is the answer at the back, I'm sure. Did anybody get that? The diagram, wasn't it? Yeah. So, if you turn to just to be clear, Arya, what you could have said at the bottom here is you could have said dy dx equals 1 over cos y, and y is sine inverse x. So you could have said this. And if you look at the bottom of page 58,
Oh, yeah.
this is where we did this before. Remember those guys? Yeah. Stupid maths with its link into the past, making me remember things. Right, who's next now? We're cycling through people.
Yeah, hold on. I had a question.
Can we sleep?
Can we sleep? Oh, you don't need to sleep. You didn't have a big lunch, did you?
No, I didn't sleep for this night.
we had lab reports due today.
Aha. That might explain why Mubarak fell asleep 4 times in my class.
Just
Are
one.
you sure it's due to the lab?
Well, yes, the other students managed to keep their eyes opened. He didn't.
Or maybe you didn't see them.
Huh?
Or maybe you didn't see them.
There was a small group. It's only this size, you know.
Questions?
Yeah, which page?
Back to 144.
Mm-hmm.
20.
144. 20.
Next class is supposed to take, right?
Next class is we're all together, yeah.
We'll see.
Yeah, interesting. What rules do you need for 2-0 on 144?
Quotient and chain.
Yeah. Yeah. Quotient and chain.
A lot of the things from the beginning, the first time with the differentiation, flipping around.
Do you want me to do it?
Yeah, I might have missed it.
Okay, let's have a look. Yeah?
Does it get as I'm getting another one better. Does it get as
Are you using the last one now?
Yes.
Warning,
Yes.
you have 1 credit left.
I know.
Okay, fine, go on.
Does do the questions in the exam get as like complicated as all? Because there's a lot of flipping around and it gets really messy. From sine to cosine.
I haven't seen one like that, but to be honest, I could imagine them asking that. It's not outside the realm of possibilities, yeah. Because it's not, I don't think it's that bad. Well, I'm going to do it now and we'll see. Okay? Yeah?
Does it come as an if?
Oh, section A question, yeah. Oh, yeah. Most commonly section A. Okay, so what rule do I need first here? Quotient rule. So that's going to be cos of x squared. Okay, then it's the bottom, which is cos of x times the top, which is, the bottom times the derivative of the top, which is minus sine x. Then minus the top times the derivative of the bottom, which requires the chain rule, and which is the outside function. This cos, and the inside function is this cos. So cos becomes negative sine, so it's sine cos x, and then you have to multiply by the inside derivative, and the derivative of cos is minus sine. So we're back to minus. Now I'll clean this up a little bit just for practice. I can definitely take the minus out. Now we have to be really careful what's in common. There's a multiplication of sine x in both, and there's a cos x in, no there's not.
No, there isn't.
Oh, that's close.
It's cosine.
Sine, cos.
There's a sine cos x and a cos x. It's cos x, sine cos x, and sine x, and cos x and sine x. The only thing that's in common is sine x, isn't it?
Yeah.
So I can take out the minus sine x, and I'm left with cos of x minus cos x times sine of cos of x.
Should it be minus? Should it be plus?
Oh, sorry, thank you. Plus over cos of x squared. Yeah, that's a hard one. That's a hard one. Because you really have to keep track of which cos and sine you're on.
It gets really complicated.
It does.
There's a lot
It
of
does.
stuff. I did not get that. I didn't get the answer.
It looks like the answer at the back, I did no simplification. I basically left it like that, didn't I? Sine cos of x, yep, minus cos, sine cos, sine, cos, sine cos, sine, yeah. And I didn't even,
There is a minus that you missed.
no, I didn't even bother to simplify the minuses in my answer. So you see, like, I have minus, which I could have just written as 1 minus. Oh, sleepy time. What's next? Look at you. Look at the state you're all in.
That's why.
This is what you get for staying up until 2 or 3 a.m. finishing your lab
No, but
report.
no,
This is what
Just
you get for
practice.
having to submit it before 9 a.m.
Did Lorraine tell you last night at 6 p.m. you'll have to submit a lab report tomorrow?
More or less, yes.
We're not allowed
Would
to.
that be accurate?
For me, yes.
There might be a time management issue here.
Can we
Yeah.
do something like interesting, like some work or whatever?
This is all interesting.
Not like work, not to work.
I had to submit both.
You getting tired of listening to me? You still have another hour of me at 3 o'clock.
I have a complex.
I need to like work
From
on it.
yesterday?
Yeah.
Okay,
Is that
that's fine. Well, if the other guys. Who's here? Who was in my extra class yesterday for Charles?
Me.
1, 2, 3. You're not Charles. 4, 5. No. 6. Okay, so I'll just do one question from that. So the people who didn't do Charles can use this opportunity to take 2 or 3 minutes of sleep And then we'll
Or
continue.
it could be in like
Or you could learn something about complex numbers. What question is it, Mo?
Number 11, sir.
I don't have it in front of me. Can you read it out? Oh, is that the one with the cos sign in it?
Yeah.
Right, read it to me.
Z1 is equal to 2 bracket cos 30 degrees plus I sine 30 degrees.
Yeah.
And Z2 is equal to 3 cos 60 degrees plus I sine 60 degrees.
And which part do you need help with?
D.
Yeah.
No, sorry, F.
Yeah.
Calculate Z1 over Z2.
Did my answer not work out?
I think I just don't. I mixed
Okay.
it up, so.
Well, what I should first do is change cos 30 and sine 30. So what is cos 30 on the calculator? No, minus.
No.
Ain't no minus. Cos 30 is root 3 over 2.
Yeah, root 3.
This thing doesn't give roots.
What is the decimal?
Cos 30, yeah. 0.8.
That's root 3 over
Root
2.
3 over 2.
And sine 30 is a half. And cos 60 is a half. And sine 60 is root 3 over 2. I think. Yeah?
Yes.
So I'll multiply the top, the 2 in. So that's root 3 plus I. And on the bottom, that 3 is a pain. So what I'll do is I'll multiply the bottom by 2. So that's 1 plus root 3i. But of course I'll have to multiply the top by 2 to balance it. So 2 root 3 plus 2i. And I'll expand the bottom. And now it's time to multiply by the conjugate. Is it? So 2 root 3 times 3 is 6 root 3. 2 root 3 times minus 3 root 3 is minus 18i plus 6i minus 6 root 3i all over 9. The middle pieces will cancel, I know that, plus 27. 3 root 3 by 3 root 3 I squared. 9 plus 27 is 36.
9.
Where is the I squared from?
I changed it to minus 1.
Wait.
Yeah, sorry, my bad.
6.
I
I have too many I's here. What the heck? Somebody shouldn't have an I there. First one doesn't.
No.
Second one does. Third one does. Last guy should have been I squared.
Squared.
Yeah. So that's 6 root 3 plus 6 root 3 is 12 root 3 minus 6i. I can divide everything by 6. 2 root 3 minus I over 6. So that is root 3 over 3 minus 1 over 6i. Or who knows.
This is a very sad question.
Thank you for your comment. It's things like that that get me through the day.
Is I under the radical or not?
Are you doing, Charles?
No.
No, so firstly, your questions are used up. You're not even doing this test. You don't even have this worksheet. Why are you annoying me? I'm tired and I ate too much for lunch.
Is I under the radical?
No.
Is the answer right or wrong?
Sort of.
It's close enough.
It's
Which number is this?
11D.
11D. Dude, that's not right. I made a mistake.
Yeah.
So
I got what you got.
isn't it larger than 27, the denominator?
Is it?
Because even the 3 gets squared, right? So it is 9 into 9 into 3.
No, because it's radical 3.
No, it's
It's
a...
radical
3 by 3 by root 3 by root 3
Yeah,
is 27, no?
9 times 3.
yeah,
Yeah.
the root square.
No, why?
Squared?
Yeah, I'm so sorry.
Yeah.
It's wrong.
Well, do you know what? Easiest thing to do would be to put it in the calculator and see what we get. And then that would answer it definitively. Can you do this on your calculator?
Yeah, I
It
forgot.
says error.
It says error.
No, you can change it to
Yeah,
imaginary.
change it.
Hey.
Where's the version of 1?
Which one should I plug in the?
Hang on, I'll show you now. My other answer's right in that question. Who knows?
I didn't check.
Who knows?
I didn't check. I can check them now if you want.
What else?
No, but like I solved them. I just didn't check if it was right.
Oh, well, why don't you check while this is loading? Because it'd be good to know if I need to change others. Because you have the answers, do you?
My paper's over there.
Oh, yeah. Well, here, just call out the question. What was on the top?
The Z1.
2 bracket
Cos 30
cost 30
plus I
plus
sin 30.
I sine 30. Close, close. And at the bottom, 3 cos 60 plus I sine 60. Root 3 over 3? Dang, I lost a 2. It's root 3 over 3 minus 1 over 3. So, I made a screw up with my second number. Right, we need to backtrack. Why is this guy wrong? It should have been, as you can see, 1 over 3, not 1 over 6. So, it's back here, right, minus 1 over 6, yeah. And I divide by 6 over 36 is 1 over 6.
That's right.
And this is, I got this last guy by doing 2 by 3 root 3. 2 by 3 is 6. 6 by, so 6 root 3. So that's right. Okay. That's right, isn't it?
Yeah.
3 minus 3 root 3 minus, and multiply in the 3 and multiply in the 2. That's right. Wait. Yes.
Oh.
Wait. 3. Oh.
So it becomes
What?
12 minus 12i. That's step which you correct.
Minus 12i.
No, as the one that the last step that's on the screen, it's 12i minus 12i. That's minus 12i. Minus 18 plus 6 is minus 12i.
Oh, I forgot how to add 18 and 6 together. Yeah, okay.
Subtract.
So, yeah. Well, adding is the same as subtracting, just with negatives. You're right, thank you. Minus 12i, minus 18 plus 6. So, if that's,
You have to divide by 12.
that's minus 12i?
Yeah, because you divide by 12 instead of 6 now. So you get.
Oh, yeah, I
you
see,
get-
because now there's 12 and
yeah, you
everything.
get 1 over 3.
So, I get root 3 minus I over 3.
Yeah.
Yeah.
Root 3 over 3 minus 1 over root 3 I. Yeah. Now, my answer at the back is...
That's still wrong.
What's the answer at the back?
Root 3.
No, but this is the correct answer, because it's used the calculator.
Yeah,
So,
the answer to the back.
the answer at the back's wrong. Now, I do wonder if the answer at the back works out to be the same as this. So, as a decimal, it's...
I'll type it.
Yeah, if you can type the answer in at the back, and we can compare. You were nearly asleep. You were... Oh, look at those red eyes. Oh, you guys are some state. Some state.
Yes.
You could be really nice and fancy.
Wait till the next.
I got something else. I got.
Lol.
This is what I got.
Yeah, so it's not the same.
Yeah.
Right, so I'll just, I'll need to... I'll fix that now so I don't forget. So who went to bed latest, do they think? You think it was you? What time do you reckon that was? 4 a.m.? Anyone can do better? Amjad beats?
I'm dead. I don't see.
You didn't sleep?
You did.
No,
Come on, 20 minutes.
still counts?
20 minutes.
Still counts?
Oh my God.
6:50 a.m.
Even not 20
6:50.
minutes. I told him it was 7, okay? I told him.
And he said, let me sleep until 8.
No, I told him.
It was 6.
Okay, I told him till 7:30.
Yeah.
No.
Then and then he wakes me up at
7:20.
7:15.
No.
He stole 15 minutes of sleep from
15
you.
minutes.
It was actually 7:50, and I had to wake you up at 8:30. So 7:50, 8:30.
Yeah.
Yeah. I
You
woke
woke
you
me up at 8:15.
I woke you up at 8:50. That's for your own good, so you attend classes earlier.
Yeah, 15 minutes, imagine.
It's disgraceful if you
15
ask me.
multiply 60 as well.
Disgraceful. Disgraceful. Well, I suppose you could have done your assignment sooner, though.
No, I did it.
Yeah,
But
but
it was Combs' fault.
I was,
He sent me the lab report draft
yeah.
late,
Okay.
so don't worry.
Okay. No, I won't. Fine. Right. Let me just save that or fix that mistake there. Do you have that answer written down? I can retype it in. Okay. So what else do we need to see? We'll have a look at one more question.
From the same thing, I can give you another one.
Right. Well, let me just fix that answer.
I can have the 15 minutes now. I lost it.
Let me just fix that answer. Sorry. So what should the answer have been?
Root 3 over 3.
Should have been root 3 over 3 plus. No, I have it here.
Minus or plus? Yeah,
Minus.
1 over 3i.
God,
What?
it's crazy.
Yeah.
I was
I hope you appreciate the effort that goes into making these worksheets. I lost my clothes brace.
So the others are right.
The other, huh?
Yeah,
Yeah,
you
we-
do 12 points.
Did I fix this? I did.
Yeah.
Okay.
The
12.
The others are right, by the way.
Yeah. Okay. Thank you.
easier, okay?
Right, can you read out 12? What was it?
You can have it.
Okay.
It's easy.
So, Z equals 1 minus root 3i. And I say you can write that in the form of or cos theta plus I sine theta. Right? So look, on the left you have 1 minus root 3i. And on the right you have or cos theta plus or sine theta I. So by comparison, or cos theta must be 1. And minus square root 3 must be the or sine theta. So or sine theta is supposed to equal minus root 3. And or cos theta is supposed to equal 1. By dividing here, or divided by or, sine over cos, tan. So tan theta equals minus square root 3. So I already have the theta. It's tan inverse minus root 3, which I think is minus 60. Minus 60. Yeah, you're right. And then all I have to do is just sub it in to say like this guy. Right? So now you have or cos minus 60 equals 1. So 1 is, or is 1 over cos of minus 60. What's that? A 2.
1 over half.
You
Yeah.
lost me, sir. How did you get 60 degrees?
Tan inverse minus square root 3.
On mole? On degree?
Yeah. Should be. I hope so.
Yeah, you're right.
Yeah. So, we can go back to the beginning and say you can write minus 1 minus square root 3i in the form equals 2 bracket cos of minus 60 plus I sine of minus 60. That if you expand this, you do get 1 minus square root 3i. Okay.
Did they get this complicated in the charts? No?
Yeah, but the good thing is, right, imagine this was in the Charles exam. how do you think they would ask it? They would say, the complex number 1 minus 3, square root 3i can be written in, this form is called a polar form, but you don't need to worry about that. It says can be written in polar form. What is its polar form? So they have to give you a multiple choice, right? So they have to give you 4 choices or whatever. So just calculate what each of the 4 answers simplifies to. And then you know which was right. So like, if they said, what does this simplify to? And one of the answers was 2 cos 30 plus I sine 30. Well, if you type in 2 times cos 30, you get something like root 3. And you can immediately stop checking. You know this answer is wrong. Because the first part of it isn't root 3, it should be 1. You know? And then you go to the next one and start to check if it could be right. See, this is the advantage of an MCQ. Yeah, exactly. Exactly. Maybe you need to go to Starbucks. Get yourself a double espresso or something. Huh?
I got one.
He
That
already
one.
drank coffee.
Huh?
Anymore, he's gonna overdose.
OD and coffee.
Fine.
He's gonna have a heart attack.
I hope the lab report was worth it.
It's what they are.
Questions are done.
It's done and dusted.
Yeah.
Okay. Did you have a class after my class?
We have medical tutorial for UCLan, but I'm not applying to UCLan, so it's free.
Huh? What medical tutorial? Is this like an application or something?
Yeah, they're gonna talk about the MMIs.
Ah, the MMIs. Yeah, okay.
So I can't do one more case.
What's next?
Implicit. Let's squeeze one in quickly.
Okay, so
Which number?
146.
Yeah.
Let's change
7. Right. X squared minus 6x, is it? Plus y squared plus 2y plus 3 equals 0. Let's all do this together. What's the derivative of x squared?
2x.
2x minus 6 plus 2y dy dx plus 2 dy dx equals 0. You can change this into 2y plus 2 dy dx equals 6 minus 2x. So that's 2y plus 2 goes down. I'll divide everything by 2. 3 minus x over y plus 1. Do I tell you what?
Yeah.
Turns up a range.
Yeah, but I said what's its value when x is 6? Now, you can sub in x, can't you?
No, x is 5.
What is it?
It's 5.
And what you know about y?
It's between minus 1 and
Yeah. But I don't tell you what it is. I just tell you what it's between. So what you need to do is sub in x is 5 and solve for y. When you solve for y, you'll get 2 answers.
It's the original equation.
Yeah. Yeah, quadratic with 2 answers of y. Which answer do you think you take?
Positive.
Positive.
No, look. I tell you y is between minus 1 and 1. You need to take the answer which is between minus 1 and 1.
Okay.
Yeah. You see, this is my, just to explain, this is my thinking here, alright? You get 2 answers for y. I didn't want to tell you in the question what y was, but I needed to let you know how to choose which answer, because you can only pick one answer. So basically I'm saying, choose the answer of y that's between minus 1 and 1.
What about if both was?
Oh, then I screwed up the question. I'm sorry. I'm sorry if that happened. Hopefully it didn't, but if it did, then I screwed it up. Or the answer is the same for both values of y. Which can happen because if you have a circle, I can choose 2 different points on the circle but get the same derivative. You know, so like it's possible. Possible. Okay. Break time?
Running so fast. You still have like 6 to 7 lessons.
Yeah, but
Spend a lot of revision.
they start to get harder, and
No, but I think if you took this in the first semester, you got more details.
What are you talking about, man?
By parts? No.
Integration.
Man, by part substitution are so different from what we did before.
Yeah, but they're all gonna take like one day, one day.
No, 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 no. Some of these lessons are quite tricky, particularly the last two lessons.
Yeah.
Will take us 2 hours to do per lesson. You know? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we'll have to give some classes over to the coursework.
Well, you know we have 8 or 9 weeks. 8 weeks.
Yeah, I know, but there's at least 3 weeks of classes we have to get through,
Yeah.
right? I'm going to assume we'll lose 1 week because, you know, one day people will be gone to MMI, or another day there'll be something else, or there'll be, you know what I mean,
Yes,
right?
yeah.
Some things like this. So the way I see it, if there's 8 weeks left, then I need 4 weeks to cover my material. That still gives me 4 weeks.
To do coursework.
No, I need 4 weeks for the workbook and the coursework. So
Work being
to finish the workbook, what I'm saying is I believe we'll have 4 free weeks. I'll use those 4 free weeks for exam papers, past papers. That's what I do every year. So for the last 4 weeks of the course, we'll open up an exam, we'll go through the whole paper, we'll finish it, we'll go to the next exam, and we'll keep going backwards and see how far we can get.
So for this question, I found the y values, and there is these. So, like.
It's the first one then.
Yeah.
Yeah.
It's just that one.
Yeah.
Is this one of our questions or Charles' question?
This one.
No, this one of ours is implicit. Implicit. Okie dokie. Take a little break. We'll start the class.
So by the answer you calculated is not matched.
Does it not?
Don't think so.
What answer did you get for y? Sorry, Mo. Sorry, what was your... everyone else can take a break if they need to. What was your answer for y?
Hold on, let me type it in again.
It was something like 0.7 or 0.8 or something. 3 minus 5 over
0.732.
732. So can you type in minus 2 over 1.732?
So minus 1.15.
Yeah?
Minus 1 plus 0.73.
Huh? Minus 1?
Yeah, I got that.
Yeah, no, but what's your final
No,
answer?
sorry, my final answer is 0.73.
Yeah, but what's the final answer on your calculator?
Minus 1.15.
Ugh. And what's the answer at the back? What number is this?
7.
7?
We might have messed it up.
Ah, no, 7 I asked you for the tangent. Yeah, so you're only half finished because all you've got there was the slope. Yeah. Now, maybe that's the same. I can see my answer is minus 2 over root 3. Can you just bash in minus 2 over root 3 and see if we get minus 1.15?
Minus 2 over
Root 3.
Yeah, it's the same now.
Good. Okay, so this checks out.
Oops.
Yeah. Okay, I'll close this now.
For the child stuff, are they gonna get